Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. So, because we still have one more week, so we have to add one more session. So, in this session, we are going to learn the comprehensive overview of text mining, text analytics, and one of the most popular applications, sentiment analysis, as they are related to the business analytics as well and the business support system. And also next semester we are going to meet again in my course, the text sentiment analysis. So this is a good introduction for you for next semester. So generally speaking, system sentiment analysis is kind of a derivation of the text mining. And then text mining is a derivation of data mining. So it's all related actually because textual data is increasing the volume right now more than data that is in the database, in the structured database. Right? So it is important for you to know some of the techniques to extract the actionable information from large quantity of unstructured data. At the end of this session, hopefully you can describe text mining and then you can understand the need for text mining. And then the next learning objective is that hopefully you can achieve the higher level of cognitive, which is analyzing, that you can differentiate between text mining, web mining, and the mine that you learn from previous sessions. And then you have to understand the different application areas for text mining, and hopefully you can know the process of carrying out a text mining project. And next one is you can understand the different methods to introduce the structure to text-based data. And hopefully you can describe what the sentiment analysis is, and then you can be more familiar with some application of sentiment analysis. And hopefully you can also learn some methods for sentiment analysis. And the last one that you can deal with speech analytics, which is part of the sentiment analysis. So in this session, you are learning the tools and techniques uh, to some smart machine to create the miracles of tackling some problems that were previously impossible to solve. Right. So this is one of the tools embedded in the Watson system. Hopefully, Abdul Wafi Abdul Kani can answer this for question from IBM TG Watson. This is a research institute in IBM. The big amount of business data, which are stored in the text document, they are virtually unstructured. So according to the study from Gartner, it's very famous on the system support system survey. He thought he achieved the conclusion that 85% of all corporate data are captured and stored in some sort of unstructured form. So the same study also stated that these unstructured data are doubling in size every 18 months. So you can imagine right now how much double, how big the data right now. Because the survey is in 2005. And because the knowledge is power in the today's business world, and the knowledge is derived from the data information, so the business that effectively tap into the text data source and efficiently tap into the text data source will have necessary knowledge to make better decisions that it can lead to a competitive advantage over those business that lag behind. So this is where the need of text analytics and text mining fits into the big picture of today's business. So text mining, also known as the text data mining or knowledge discovery, is the semi-automated process of extracting patterns uh, or knowledge, because pattern can be also part of the knowledge, useful information and useful knowledge from large amounts of unstructured data sources. So this figure illustrates the relationship between text analytics and text mining, um, with other related application areas. So the bottom part of the figure lists the main disciplines, like foundations of the house, right? So if you have strong foundation, then your house will be very strong, right? Because they are playing a critical role in development of this house, these increasingly more popular application areas. Remember that data mining is the process of identifying valid patterns, novel patterns, potentially useful pattern, and ultimately understandable patterns in your data that stored in the structured database, right? So where the data are organized in records structured by categorical variables, ordinal variables, continuous variables, right? That's the one that you have it in the structured database. So text mining is the same as data mining in that it has the same purpose and uses the same processes. But with text mining, the input to the process is a collection of unstructured data or less structured data, at least. The files, such as Word documents, PDF files, text excerpts, XML files, and many in you already experienced a lot of this kind of files. So in essence, text mining can be thought as a process with two main steps that start with the imposing structure of on the text-based data source, that followed by extracting relevant information and knowledge from the structured text database, text-based data, structured text-based data, not database, using the data mining techniques and tools. Benefits of text mining are obvious in the areas where very large amount of textual data are being generated. For example, law, right? Where you have court orders. I have one paper published this year about the court orders, text mining. And then academic research, where you have some research articles, huge amount of research articles that shape the world, right? And then in the area of finance, where you have quarterly reports, for example. And then you have in the field of medicine, where you have some discharge summaries data. And in the biology, you have molecular interactions. And in the area of technology, you have some patent files. And the marketing, you have some customer comments, right? So for example, the free-form text-based interaction with customers in the form of complaints, or not just complaint, actually praise also the products, the service, and the warranty claims, right, can be used to objectively identify the product and service characteristics that are that are deemed to be less than perfect and can be used to as an input to better product development and service allocations. Another area where the automated processing of unstructured text has a lot of impact is in the electronic communication and email. You have text mining, which is not only can be used to classify the junk email and also filter the junk email after that, but it can also be used to automatically prioritize email based on the importance level, as well as generate automatic response. Another text mining application area is information extraction, where you have an identification of key phrases and relationship within the text. And then another one is topic tracking, which is based on the user profiles and documents that user views. So text mining can predict other documents that of interest to the user, right? Or people call it as a topic modeling. And then we have summarization. This is important for document, and then you summarizing the document to save time, not reading all the documents, right? And then categorization, where you can identify the main theme of document and then placing the document into a predefined set of categories. And then you have clustering, right? Very famous in data mining, where you can group similar documents without having predefined set of categories. And then you have concept linking, where you connect related documents by identifying their shared concept, and by doing so, you can help the users to find information that they will not find using traditional search methods. And then the last one is question answering, where you can find the best answer to the given question through the knowledge-driven pattern matching automatically. So the first application case is about pattern analysis text mining. Hopefully, Iqmal Daniel can answer this for questions. Some of the early text mining application used a simplified representation that we call as a pack of words when introducing structure to a collection of text-based documents in order to classify them into two or more predetermined classes, or to cluster them into natural groupings. It's very famous one, pack of words, until now still famous, with some proven experimental designed methodology. Then the prediction results are quite good, but the results are not much better than simply guessing, which may indicate that the back of the word is not generating a good enough representation of the research articles in these domains. So, more advanced techniques such as natural language processing are needed. So, NLP is an important component of text mining and is a subfield of artificial intelligence combined with computational intelligence. Computational linguistics. So it studies the problem of understanding natural human language with the view of converting depiction of human language, such as textual document, into more formal representation in the form of numeric and symbolic data that are easier for computer programs to manipulate. So the goal is to move beyond syntax-driven text manipulation, which is called as a word counting, to a true understanding and processing of natural language that considers grammatical and semantic constraints as well as the context. The definition and the scope of the word understanding is one of the major discussion topics in NLP. So let's consider the natural human language in that is vague, that a true understanding of meaning requires extensive knowledge of a topic beyond what is in the word, sentences, and paragraphs. Will computers ever to able to understand the natural language the same way and with the same accuracy that humans do? Probably not. It's impossible. Human can be can be similar to the machine, right? But at least as close as human has come along the way from the days of simply word counting, but it has been even longer ways to go to the really understanding natural human language. So this is a big question. So there are some challenges commonly associated with the implementation of NLP. The first one is part of speech tagging. So it is difficult to mark up the terms in the text as corresponding to a particular part of speech. POS. POS can be nouns, verb, effect, adjective, adverbs, right? So, because the POS, part of speech, depends not only on the definition of the term, but also on the context within which is used. The next challenge is text segmentation, because some written languages such as Chinese, Japanese, Malayus, they don't have single word boundaries. In these instances, the text parsing task requires the identification of word boundaries, which is often a difficult task, similar to the challenges in the speech segmentation uh, when analyzing spoken language, because sounds, your spoken language, represent successive letter and words blend into each other. Uh, The next challenge is word sense and disambiguations. So many words have more than one meaning. So to select the meaning that makes the most sense can only be accomplished by taking into account the context within which the word is used. The next one is syntactic ambiguity. Because we have the grammar for natural language is ambiguous, then multiple possible sentence structure often need to be considered. So you have to choose the most appropriate structure, usually requires a fusion of semantic and contextual information. Next challenge is imperfect input or irregular input, because you have foreign accents and local accents and vocal impediments in the speech and typographical or grammatical errors in the text, then you can make the processing of the language an even more difficult task. The next challenge is speech act, because this sentence can often be considered an action by the speaker. The sentence structure alone may not contain enough information to define the action. For example, can you pass the class request a simple yes or no answers, whereas can you pass the salt is a request of physical action to be performed. So it is a long-standing dream of the artificial intelligence community to have algorithms that are capable of automatically reading and obtaining knowledge from the text. So by applying a learning algorithm to parse text, some researchers from Stanford University's NLP laboratory have developed methods that can be automatically identifying the concepts and the relationships between those concepts in the text. So they are applying a unique procedure to large amount of text, and their algorithm automatically get hundreds of thousands of items of word knowledge and use them to produce significant enhanced repository that we call it as a WordNet. So WordNet is a huge hand-coded database of English words. So their definition, their set of synonyms, and various semantic relations between synonym sets. So it is a major resource for NLP applications. But it has proven to be very expensive to build and maintain manually. So an important area where NLP is making significant impact is sentiment analysis. So sentiment analysis is a technique used to detect favorable opinions and unfavorable opinions toward specific products and services using large number of textual data sources. For example, customer feedback in the form of the web postings, forum, right? So the detailed coverage of sentiment analysis and WordNet will be discussed in the next few slides. So text mining is also used in to assess the public complaints. So this application case, you can see the example of where text mining is used to anticipate the public complaints and address the public complaints in Hong Kong. Hopefully, Isian can answer these two questions. NLP has successfully been applied to a wide domains for a variety of tasks using the computer programs to automatically process natural human language that previously cannot be done by humans. So these are the most popular tasks: question answering. The first one is information retrieval, right? Or the information extraction, right? Where you have also named entity detection, and then you have question answering. This is automatically answering a question posed in natural language, that is produce human language answer with given human language questions. So to find the answer, usually the computer may use either the pre-structured database or collection of natural language documents. They call it as a corpus. And then we have automatic summarizations. So the creation of the shortened version of textual document by a computer program. They contains the most important points of the original document. We call it as a summary, right? like summarize your project as an abstract. It's very important feature then. And then we have natural language generation and understanding, where you have systems converting information from computer database into readable human language, and also convert samples of human language into more formal representation that can be manipulated by the computer programs easily. And we have machine translation. This is my PhD thesis about, where we have automatic translation from human language to another language, right? And then we have foreign language reading and writing, where this computer program can assist a normative language speaker, non-native speaker, to read the foreign language with correct pronunciation and accents on different parts of the word. And then the writing is the one that you can assist them to write these non-native language users to write in a foreign language. And we have a speech recognition there, when we have a converting spoken words to machine readable input. And then we have text to speech, where you can also call it a speech synthesis. This is the computer program that automatically converts normal language to text into the human speech. Or you can have optical character recognition. This is the automatic translation of the image, where you have handwritten and typewritten. Typewritten is very easy. Printed text is also quite easy, but handwritten is quite difficult uh, to convert it into machine readable textual document. So this figure gave you an illustration of a simplified depiction of a multi-level text analysis process of discovering gene protein relationship for protein interactions in the biomedical literature. As you can see here in this simplified example, uh, you can see this uses a simple sentence from biomedical uh, text. First, at the bottom three levels, the text is organized using the part of speech, POS, tagging, and shallow parsing. And then the tokenized terms, which is the word, are then matched and interpreted against the hierarchical representation of the domain ontology. Right? The ontology is like a tree, right? But specific to each domain to derive the gene protein relationships. So the applications of this method and some variation also to the biomedical literature offers you great potential to decode the complexity of the Human Genome Project as a result here. So as I mentioned previously, that text mining has a wide variety of applications in a number of different disciplines. So you can see this application case, for example, of how financial services company is mining to improve the customer service performance. Hopefully, Rashik Daniel can answer these two questions. In order to be successful, text mining studies should follow a second sound methodology based on the best practice. So the standardized process in data mining is CRISPR-DM, right? So we can have similar one, which the most part of the CRISPR-DM are also applicable to text mining projects. So a specific process model for text mining will include much more elaborate data preprocessing activities. So this quite important for you when you have a project in your final year project to have a framework. Can be CRISPR-DM, can be KDD, right? For text mining. Here, this figure give you high-level context diagram. Like in UML, you have context diagram, right? And then this is the high-level one of a typical text mining process. So this context diagram presents the scope of the process, emphasizing its interfaces with the large environment. So in essence, it draws boundaries around a specific process to explicitly identify what is included in the text mining process and what is not included from the text mining process. So as you can see in this context diagram, the input inward connections using the inward arrow to the left edge of the box into the text-based knowledge discovery. The process is unstructured as well as unstructured data collected, stored, and made available to the process. So the output, which is the outward extension from the right edge of the box of the process, is the context-specific knowledge that can be used for decision making. The controls that we call as a constraints inward connection also. Right? Uh, on the top of the box is the process, includes software and hardware, and privacy issues and link and the difficulties related to the linguistic, the text processing that is presented in the form of natural language. And the mechanism, this is the mechanism, inward connection at the bottom of the box of the process, include proper techniques, software tools, and domain expertise. Right? So the primary purpose of text mining within the context of knowledge discovery is to process unstructured textual data along with structured data, if relevant to the problem being addressed and available, to extract the meaningful and actionable problem for better decision making. At a very high level, the text mining process can be broken down into three consecutive tasks: task 1, task 2, and task 3. Right? Each of the tasks has specific inputs to generate certain outputs. Right? If for some reason the output of the task is not what expected, then the backward redirections to the previous task execution is important. So let's discuss in detail the steps. The first step, establish the corpus. The main purpose of the first task activity is to collect all of the documents related to the context. Context is like a domain of interest that you are studying. So this collection may include textual documents, XML files, emails, web pages, and short notes. Right? So in addition to the readably available textual data, voice recording also can be transcribed using the speech recognition algorithms and made a part of the text collections. Once collected, the text documents are transformed and organized in a manner such that they are all in the same representational form, which is, for example, ASCII text files for computer processing. So the organization of the documents can be as simple as a collection of digitalized text excerpts stored in the file folder, and it can be a list of links to a collection of web pages in a specific domain. So many commercially available text mining software tools can accept these as inputs and convert them into a flat file for processing. As an alternative, that flat file can be prepared outside of the text mining software and then presented as the input to the text mining application. Task number 2, create the term document matrix. So in this task, the digitized and organized documents, which is the corpus, are used to create TDM, term document matrix. So in the TDM, rows represent the documents and column represent the terms. Right? So the relationship between the terms and documents are characterized by the index, right, which is a relational measure that can be as simple as the number of occurrence of the terms in respective documents. Right. So this is a typical example of TDM. The goal of this step is to convert the list of organized documents, the corpus, into a TDM, where the cells are filled with the most appropriate index. So the assumption is that the essence of a document can be represented with a list and frequency of the terms used in the documents. But are all terms important when characterizing the documents? Obviously, the answer is no. Some terms such as articles, auxiliaries, right, and terms used in almost all of the documents in the corpus have no differentiating power. It's very important power, and therefore should be excluded from the indexing process. So this list of terms, commonly called stop terms or stop words, is specific to the domain of the study and should be identified by domain experts. On the other hand, you might choose a set of predetermined terms under which the documents are to be indexed. This is the list of terms conveniently called include terms or dictionary. In addition, synonyms, which is the pair of the terms that are to be treated the same, and specific phrase, for example, Eiffel Tower is very specific, right? Can be provided also so that the index entries are more accurate. Another filtration that should take place in accurately creating the indexes is stemming, so which refer to the reduction of the words to their roots. For example, different grammatical forms or declination of a verb are identified and indexed as the same word. For example, the stemming will ensure that the modeling and the modeled, these two words, will be recognized as the word model. So because model can be extended into modeling and modeled, right? Past and continuous form. So this first generation of the TDM includes all of the unique terms identified in the corpus as its column. It excludes the ones in the stop term list, all of the document as the rows, and the occurrence count of each terms for each document as its shell values. If, as is commonly the case, the corpus includes a rather large number of documents, that there is a good chance that the TDM will have a very large number of terms. Processing such a large matrix might be time-consuming to process the matrix, and more importantly, might lead to extraction of inaccurate patterns. So, so at this point, you should decide what is the best representation of the index. So these are few of the most commonly used normalization methods, which is log frequencies, row counts, binary frequencies. Right? The binary frequencies is even simpler transformation that can be used to enumerate whether the term is used in the document. Log frequencies is the row frequency can be transformed in using the log function. So this transformation would dampen the row frequency and how they affect the result to the subsequent analysis. And then you have inverse document frequency, where uh, another issue that can consider more carefully and reflect in the index used to further analysis in related document frequency of the different terms. Because TDM is often very large and rather sparse, most of the cells filled with zeros, another important question is how do we reduce the dimensionality of the matrix to a manageable size? So several options are available for managing the matrix size. First, through the domain expert, he goes through the list of terms and eliminate those that do not make sense for the context of the study. This is the manual, labor-intensive process. Second, you can eliminate terms with very few occurrence in very few documents. And then you can also transform the matrix using a singular value decomposition, SVD. SVD is closely related to the principal component analysis, PCA. These two things are reducing the overall dimensionality of the input matrix, which is through the number of input documents by number of extracted terms to a lower dimension space, where each consecutive dimension represents the largest degree of variability between words and documents possible in the SVD. Task number 3 is extract the knowledge or patterns. So using the well-structured TDM and potentially augmented with other, such as structured data elements, novel patterns, are expected to in the context of specific problems being addressed. The main categories of knowledge extraction methods are classifications, and we have also clustering, association, and trend analysis. So classification is the most commonly knowledge discovery topic, right? In analyzing complex data source in the classification or categorization, people call it as a text categorization of certain objects. So the task is to classify given data instance into a predetermined set of category or classes. So you already familiar with this one. And then we have clustering is an unsupervised process where the objects are classified into natural groups. They call it as a cluster. They don't have labels, they don't have classes yet. So that's why it's unsupervised. If the assumption holds, the clustering of documents based on the similarity of their content improves the search effectiveness of improved searching recall. So clustering, because it is based on the overall similarity as opposed to the presence of singleton, it can improve the recall of a query-based speech, query-based search in such a way that what a query match to the document in whole cluster is returned. And then it can also improve search precision. The clustering can also improve it with the two most popular clustering methods, scatter-gather clustering and query-specific clustering. Right? For associations is a popular and well research technique for discovering interesting relationship among variables in large database. And then trend analysis is applied for large number of academic articles that you can publish 3 highest rated academic journals and then to identify the evolution of key concepts in the field of information system as an example. So there are number of methods available for text mining. Hopefully this application case, you can learn some use of number of different techniques in analyzing large set of literature. Hopefully Nur Hasiko can answer these 2 questions. As the value of text mining is being realized by more organizations, the number of software tools offered by some software companies and non-profit organizations is also increasing. So these are the most popular text mining tools that you can use to classify the tools into commercial ones and free ones. So the commercial one offer you the demonstration of version of their products on their website that you can trial version. For example, the IBM offer SPSS modeler and data analytics toolkits. And then you have SAS Enterprise Text Miner provides you rich suite of text processing and analysis tools. And then you have Statistical Data Miner that has an engine to provide easy to use text mining functionality with an interesting visualization capabilities. And then you have Clear Forest, give you analysis and visualization tools also. For free software tools that you can use from non-profit organization, you can use RapidMiner, one of the most popular free open source software tools for data mining, and tax mining also. So you can tailor this with graphically drag and drop user interface in RapidMiner. And the Git is a leading open source toolkit for text mining. It has free open source framework for SDK and graphical development environment. And we have SpyM or SM, which is a text classification system that learns from positive and unlabeled examples. Often, an innovative application of text mining comes from the collective use of several software tools. So this application case gives you a few customer case study synopsis where text mining and advanced analytics are used to address the variety of business challenge. So hopefully Wallace can answer these 5 questions. Now it's a sentiment analysis that we are going to learn in detail next semester. But here you just see the overview. So sentiment is basically a difficult word to define. So it is often linked to with other terms such as belief, view, opinions, convictions. Right? So as a field of research, sentiment analysis is closely related to the computational linguistics, close to the NLP, close to text mining. So sentiment analysis has many names. It is often referred to as opinion mining, subjectivity analysis, pressure extraction, although they might have a different definition there, with some connection to the affective computing. Affective is not cognitive. It's computer recognition and expression of emotions. So sentiment analysis is trying to answer the question, what do people feel about a certain topic, by digging into opinions of many using a variety of automated tools. The sentiment that appears in the text comes into two flavors, explicit and implicit. Explicit, where the subjective sentence directly expresses the opinion. For example, it's a wonderful day. Right? An implicit sentiment, where the text implies an opinion, implying, for example, the handle breaks too easily. So if you read fast, you cannot understand the sentiment, but if you dig into it, it's implicitly gives the negative sentiment. So we have a sentiment polarity here, right, of any particular feature of the text that sentiment analysis primarily focus on. So it's usually dichotomized into two positive and negative. But polarity can also be thought as a range. And then we have a document containing several opinionated statements will have a mixed polarity overall, which is different from having a polarity at all, which is being neutral or objective. So these are the real analysis of textual data, which are often visualized in easy to understand the dashboard. So Authenticity is one of these companies that provide this solution to companies' text analytics needs. So for example, here we have social media analytics dashboard created by the company Authenticity. You have the conversation, and then you can analyze whether it's providing positive or negative. Very convenient tool. Because the complexity of the problem, uh, um, there is no readily available standardized process to conduct sentiment analysis. But based on the published work in the field of sensitivity analysis, so far both of the research method and range of application, a multi-step simple logical process can be like this. Right? So this kind of appropriate methodology for sentiment analysis, these logical steps are iterative. It is iterative uh, through this one. Sorry, you cannot see the line here, but it's like an iterative here. Right? So these iterations give you the feedback, corrections, and iterations are based on part of the discovery process and the experimental in the nature, and once completed and combined, capable of producing desired insight about the opinions of the text collections. Right. So let's discuss those steps one by one. Step number one, sentiment detection. So after retrieval and preparation of text document, the first main task is sensitivity analysis, is the detection of objectivity. So here the goal is to differentiate between the fact and opinion, which may be viewed as classification of text as objective or subjective. So this may also be characterized as calculation of 0 to 5. Sorry, OS, polarity, objectivity and subjectivity polarity. So which may be represented with a numerical value from 0 to 1. Right? And then step number 2 is polarity classification. This is the second main task that is giving you the opinionated piece of text, and the goal is to classify the opinion as falling under one of two opposing statements polarities. So to locate its position on continuum between these two polarities when viewed as a binary feature, polarity classification is the binary classification task of labeling an opinionated document as expressing either an overall positive and overall negative. For example, thumbs up and thumbs down. How many thumbs up and how many thumbs down? So the step number 3 is target identification. The goal of this step is to accurately identify the target of the expressed sentiments. For example, a person, a product, an event. So those are different expressions. But the difficulty of this task depends largely on the domain of the analysis. Even though it is usually easy to accurately identify the target for product or movie reviews, because the review is directly connected to the target, right? So it may be quite challenging in another domains, not uh, general domains. Step number 4 is collection and aggregation. Once the sentiments of all text data points in the document are identified and calculated, in this step, they are aggregated and converted into a single sentiment measure for the whole document. As I mentioned earlier, the polarity identifications, identifying the polarity of a text, can be made at the word level, or the term level, or the sentence level, or the document level. The most granular level of polarity identification is at the word level. Once the polarity identification is made at the word level, then it can be aggregated to the next higher level, and then the next until the level of aggregation desired from the sentiment analysis is reached. There seems to be two dominant techniques used for identification of polarity at the word level or term level, each having advantage and disadvantage. First, using lexicon as a reference library, either developed manually or automatically by the individual or for specific task or developed by an institution for general use. Perhaps the most popular general-purpose lexicon is WordNet, created at Princeton University, which has been extended and used by many researchers and practitioners for sentiment analysis purpose. So as described in the website, wordnet.princeton.edu, and until now you can access it. It is a large lexical database of English, including nouns, verbs, adjectives, adverbs grouped into a set of cognitive synonyms, which is synsets, each expressing a distinct concept. A similar extension methodology is used to create SentiWordNet. It's a publicly available lexicon specifically developed for opinion mining or sentiment analysis purpose. The second method is using a collection of trained documents as the source of knowledge about the polarity of terms within a specific domain, which is inducing predictive models from opinionated textual document. So it is possible to perform sentiment classification using statistical analysis and machine learning tools to take an advantage of vast resource of labeled manually annotated using the star point system document available. An interesting extension of WordNet was created by some researcher in 2006, where they add polarity, positive and negative, and subjective and objective, the objectivity, the labels for each term in the lexicon. So to label each term, they classify the synset, a group of synonyms to which this term belong, using a set of ternary classifier. Ternary is like a measure that attached to each object exactly one out of three labels, each of them capable of deciding whether a synset is positive or negative or objective, right? Not subjective. So this one is subjective. The option, another option is objective, like neutral. Right? So the result scores range from 0 to 1, giving a great evaluation opinion related properties, the terms. So this can be seen like this figure. Right? The edge of triangle represents one of the three classifications, and the term can be located in this space. Right? As a point here or here or here, representing the extent to which it belongs to each of the classification. Which one? It's three. Right. Okay. Last topic is speech analytics. So this is the growing field of science that allows users to analyze information and extract information from both live conversation or maybe recorded conversations. The core of automated sentiment analysis centers around the creating of model to describe how certain features and content in the audio relate to the sentiments being felt and expressed by the participants in the conversations. So two primary methods have been displayed and deployed to predict sentiment within the audio: acoustic, phonetic, and linguistic modeling. So the acoustic approach to sentiment analysis relies on extracting and measuring specific set of features, for example, tone of voice, pitch or volume or intensity, the rate of speech, right, of the audio. So the most common ones are intensity, which is like energy, sound, pressure level, and the pitch. Pitch is a variation of fundamental frequency. And you have a jitter. This is a variation of amplitude of vocal fold movements. And we have shimmer, is a variation in frequency of vocal fold movements, and others, for example, glottal pulse, speaking rate, and so on. And then the second approach is linguistic approach. So the linguistic approach focuses on the explicit indicators of the sentiment and context of the spoken content within the audio. The linguistic models can acknowledge that when in a charged state, the speaker has a higher probability of using specific words. So you have exclamation of the phrase in particular orders. So this feature that are most often analyzed in the linguistic model include lexical words, phrases, and other linguistic patterns. So you can also these fluencies, which is filled by pauses, hesitation, restart, and nonverbal such as laughter and breathing. Right? So you have higher semantics taxonomy here, and also ontology, dialogue history, and pragmatics. And you can see many use exist for speech analytics and the use case as well. So that's all for this session. If you have any question, you can discuss it during the discussion session for application case studies discussion. See you there.